In this lesson, we're going to start our unit on similar polygons by talking about ratios and proportions. So first, the distinction between a ratio and a proportion. A ratio is a single relationship between two things. So it can be represented as a fraction or with like the colon between it. And then a proportion is when you take two ratios and set them equal to each other. So we're going to look at some conversions because conversions use ratios. And they come from some different measurement systems. So the first thing is if we're talking about meters, meter is a metric unit. So that's using the metric system, and we'll talk about these different prefixes for the metric system. In metric conversions, if we have 1 meter, that is 1,000 millimeters. 1 meter would be 100 centimeters, and then like 1 kilometer is a common unit of measurement, and that would be 1,000 meters. So that's based on the metric system. Some imperial conversions, which is the unit of measurement that we use in the United States. 1 foot is 12 inches, 1 yard is 3 feet, and we can also say that 1 yard is 36 inches by converting those feet into inches. For time, 1 week is 7 days, 1 hour is 60 minutes. Same, 1 minute is 60 seconds, and 1 day is 24 hours. So those are some common time conversions. And then some other things are converting between systems. So 1 mile is 1,760 yards. 1 pound is 16 ounces, and 1 gallon is 4 quarts. So those are some common measurements that you might need in this unit. So if we're talking about the metric system always starts with a base unit. So if we think about what the units could be, like if we're talking about distances, we'd use meters. If we were talking about liquid measurements, we would use liters. And weight is measured in grams. So if we just choose one of those, the base unit, so a few things, we can have meters, and that's an M. We can have liters, which is an L. We can have grams, which is a G. And all of those can be base units. So if we use that as a base unit in the metric system, on this chart, the ones to the left are smaller, and the ones to the right are larger. So this is based on a base of 10. So if we use one of these units, let's just choose one as an example. So if we choose a gram as our base unit, then we would be talking about like 1 gram. The prefix deci means a tenth. So this would be 1/10 of the base unit. 1/10 times the unit. So if we're thinking about a gram, so there would be 10 decigrams in 1 gram. So 1/10 of a gram is a decigram. A centigram, centa is a common prefix for 100. So this is 100th of a unit. So there would be 100 centigrams in 1 gram, or 100 centiliters in a liter, 100 centimeters in a meter. Next is a milli. Milli is the prefix, so that is a prefix for 1,000, like the millennium is 1,000 years. So that would be 1/1000th of a unit. And that means that there would be 1,000 of whatever we're talking about. So if we're talking about meters, liters, or grams, there are 1,000 milligrams in 1 gram. So down here, these are smaller, so there's going to be more of the one with these prefix than the original. Okay, so now if we're talking about these to the right, these are larger. So deca, like desa, is tenth. Deca is 10 times. So this would be 10 of the units. So 1 decagram would equal 10 grams because the decagram is larger than the gram. A hecto is 100. So 1 hectogram would be 100 grams. And kilo is 1,000 units. So 1 kilogram is 1,000 grams. So that's how you can convert using the metric system. So depending on what unit you're using, you can use these in ratios. So ratios compare two things. One thing about ratios is that they have no units. So if we have a ratio set up with units, we need to get them into common units first. So we're going to convert to common units first. So here I have 1 meter to 2 kilometers as the ratio. So this would be like a ratio on a scale model or something. So 1 meter to 2 kilometers. So if I'm going to change kilometers to meters, I look at kilo as my reference unit, and that is 1,000 of the units. So 2 kilometers would be the same as 2,000 meters. 2 kilometers is 2,000 meters. So 1 meter to 2,000 meters. I get it to where my units match, and that way they cancel out. So here, once I cancel out my units, my ratio is 1 to 2,000. So it can be written as a fraction, or it can be written with the colon, so 1 to 2,000. So if I'm using ratios, I want to make sure that in a single ratio, my units match so that I can have a common ratio. All right, so here in the next one, we have 3 yards to 6 feet. So we want to get these into common units. I can change yards to feet by looking at my comparison here. So 1 yard is 3 feet. So if this is 3 yards would be the same thing as 9 feet. So 3 yards equals 9 feet. That's because each yard has 3 feet in it. So 3 times 3 is 9. So that would be 9 feet over 6 feet. So the units cancel out. And then I just want to see if it will reduce. This one will reduce. The previous one didn't. 9 over 6 will reduce to 3 over 2. So it can be written as a fraction or with the colon in between. So 3 to 2 is my ratio. So I just want to change it so that it has common units, and then I can simplify. So next we're going to start talking about proportions, and a proportion has 2 ratios set equal to each other. So when we're solving proportions, or if we're looking at proportions, we have some properties that work. So the cross products, if we have a proportion, then the cross products will be equal. So that means that we can multiply A times D and B times C, and those will be equal to each other. Another property of proportions is the reciprocals are equal. So if I have A to B equals C to D, A over B equals C over D, I can flip both of those ratios over so that B over A is equal to D over C, and those will be equivalent. So equivalent ratios have equivalent cross products. So to solve proportions, we use cross products. So when I'm looking, I'm going to multiply my cross products. So here I have 8 times 3, which is 24. So let me write out my work first. I did 8 times 3, and that gave me 24. And then I'm going to multiply my other cross product, which is 2 times n, which is 2n. So here, the equation that I'm going to solve now is 24 equals 2n. And so then I can divide by 2 on both sides, and I get that n equals 12. So I just want to get that variable by itself to solve that proportion. So sometimes it takes a little bit more work than that. So on this one, As I go to multiply, I notice that there's two terms on the bottom of this second ratio. So that's going to be 4 times n plus 14, and that's going to be equal to 7 times 10. So if I have two terms, both of those terms have to be multiplied by the 4 that was across from it. So it's kind of like the distributive property here. It's exactly like the distributive property here. So I have 4 times n is 4n, and then 4 times 14 is 56. So 4n plus 56 equals, and then 7 times 10 is 70. So then I'm going to solve this by subtracting 56 from both sides. So I get 4n equals 14. And then I divide by 4, and it's okay if it doesn't divide out all the way. So this one doesn't. I can simplify this because both of them are divisible by 2. They're both even. So the reduced version would be 7 over 2 or 3.5. And that would make that ratio equivalent to the first one. All right, so looking at this last one, if we use cross products to solve, I have 12 times b plus 6 equals 9 times b. So when I distribute, this is 12b plus 72, and that's going to be equal to 54. So I'm going to subtract 72 from both sides. All right, so 12b equals, let's see, that's going to be negative 18. Okay, so then I'll divide by 12, and b equals negative. Both of these are divisible by 2. So if I divide by 2, that would be negative 9 over 6. That one's also divisible by 3. So really, I didn't divide by my greatest common factor. My greatest common factor between those two would have been 6. And that'll give me negative 3 over 2 as the value of my variable. So negative 3 over 2 is b. So we can use cross products to solve. It's not always going to give us a whole number as our answer for the value of the variable. All right, so sometimes our problems can give us an extended ratio, which tells us the relationship between three different things. So the angle measures of a triangle are in the extended ratio 3 to 4 to 8. So we're able to solve this problem because I know what the angle measures have to be equal to. So since this is a triangle, the triangle sum of the interior angles is 180 degrees. So these three angles have to add up to 180 degrees. I know their ratio is 3 to 4 to 8. So that's going to be reduced. In order to unreduce it, I need to figure out what the scale factor is. So the scale factor, since I don't know, I'm just going to choose something for it. Here I can say that the scale factor is x. So I know that these three values are 3 to 4 to 8. So it's going to be 3 times whatever that scale factor is, 4 times whatever that scale factor is, and 8 times whatever that scale factor is for those angle measures. So altogether, they have to have this angle sum of 180 degrees. So I'm going to add it together, 3x plus 4x plus 8x, and that's going to equal 180. So 3 plus 4 is 7, and then 7 plus 8 is 15. So 15x equals 180. So if I divide by 15, that's going to help me find that scale factor. So x equals, and then 180 divided by 15 is 12. So 180 divided by 15 is 12. So this tells me the scale factor. So 12 is the scale factor. This problem said to find all of the angle measures though. So if I do 3 times the scale factor of 12, that's going to give me 36 degrees. Then I do 4 times the scale factor of 12, which will give me 48 degrees. And the last one was 8 times the scale factor of 12, and 8 times 12 is 96 degrees. So if I just want to test it and add these all together, just to make sure, these are my three angle measures. I'm just going to test it to make sure, so I'm going to add these two together. 36 plus 48 is 94, or not 94, 84. 84. And then 84 plus 96 is 180 degrees. So those are the three angle measures that have that ratio, 3 to 4 to 8. And they have an angle sum of 180 degrees. So those are the three angle measures of that triangle. Another way we can use ratios is we can have an extended ratio for the side lengths, but we're going to need some more information because the sides don't have a certain thing that they have to add up to. So we're going to set up a proportion to solve for x. So this tells me DE to EF to DF is 4 to 5 to 6. So if I want to solve for x, let's figure out where the x is. So the x is on EF. So I know I need to use EF. And then I need to use one of the other sides. So I kind of want to make it where what I'm using, let me say EF in red because that's how I had it underlined in the original. I want to make it easy on myself. So the easiest measure here, looking at the triangle, is the one with the whole number. So it has 16. So I'm going to say EF to DE is the proportion I'm going to use. So set up a proportion. This is my guide. So I always like to have a guide to tell me what I'm looking at. So I know the ratio of EF and DE. So if I look at these, the ratio EF is 5. So based on the ratios, and then based on the diagram. So the first ratio I'm going to set up is based off this extended ratio. So in the extended ratio, EF is 5. And in the ratios, DE is 4. So EF to DE has a ratio of 5 to 4. Then I'm going to look at my diagram and set up that same ratio of EF to DE. So in the diagram, EF is represented by X, and DE is represented by 16. So here is my proportion that I'm going to solve. So sometimes the scale factor might jump out at you to figure out what the multiplier is, but the cross products are always going to work. So let's solve this using our cross products. So I'm going to have 5 times 16 equals 4 times x. 5 times 16 is 80. So 80 equals 4x. And then I can divide by 4 on both sides. And that tells me that 20 is my value of x. So what you might have noticed is that from 4 to 16, it multiplied by 4. That's your scale factor. So you could have also used that scale factor to figure out the value of x. But the cross products always work, especially if it's not going to be a whole number as your scale factor. All right, so now that we know the value of x, we can find all of the side lengths because they're represented with x's. So the length of EF is going to be 20 units. And then the length of DF is going to be 20 plus 4, which is 24 units. So this, how this works with this extended ratio is here's the ratio of the side lengths just based on their raw numbers. We always want to reduce our ratios, so all of these have a common factor of 4. So if I divide them all by 4, that's where the 4 to 5 to 6 comes from. So my side lengths are 16, 20, and 24. The extended ratio is 4 to 5 to 6. And they have that common scale factor of 4. All right, so that's how we're going to be using ratios and just kind of our introduction to ratios and proportions.